Okay, so in this video, we're basically going to recap all the identities that we have done, right? You should have seen all of these before, and you will need to know these for the exam. So this is something that you will need to memorize along with your trig table. All right, so the first thing we're going to do is we could talk about the reciprocal identities. Okay, and we have 6 reciprocal identities. The first one we have is cosecant theta is 1 over sine theta. All right, second one we have, and obviously to go along with that we have number 2, which is sine theta is 1 over cosecant theta. Okay, the second one we have is secant theta is equal to 1 over cosine theta, and then that can be paired up with the other identity, which is number 4. This should be number 3, and that is cosine theta is 1 over secant theta. Okay, and then we have number 5, which is cotangent theta is 1 over tangent theta, and we can pair that up with tangent theta, so that would be number 5 is going to be 1 over cotangent theta, right? So these are your 6 reciprocal identities. And again, like I said, you should know these because we've done this quite a few times in class. Next, we have something called the quotient identities. And again, these are something that you should know because that's how we define these, and the functions are tan theta equals sine theta over cosine theta. Okay, and we can pair this up with cotangent theta equals cosine theta over sine theta, right? So we have tan and cotangent, which can be written as quotients, and then we have what we call the Pythagorean identities. And those are 3. The first one is sine squared theta plus cos squared theta equals 1. Then we have tan squared theta plus 1 equals secant squared theta. And then cotangent squared theta plus 1 equals cosecant squared theta. Okay, and finally we have the even and odd properties. Okay, if you remember the graph of a sine function, and we saw that the graph of the sine function was actually symmetric about the origin, right? And we know that functions that are symmetric about the origin are actually odd functions. So sine happens to be an odd function, so we know that sine is an odd function, which means sine of negative x is actually negative sine x. Okay, well, pair that up with cosecant, which is 1 over sine, so we know that cosecant x of negative x is negative cosecant x. So obviously, if sine is an odd function, 1 over sine also has to be an odd function. Second, we know that cosine was actually symmetric about the y-axis, which makes that even. So cosine of negative x is actually equal to cosine of x, and secant of negative x equals secant of x. All right, and then the third one is, think about dividing these. If I divide sine negative x over cosine negative x, I'm going to get tan of negative x, right? Because remember, tan was sine over cosine, so if I divide these two, I get tan of negative x, which will make negative sine x over cosine x is negative tan x, which makes tan also an odd function, right? So sine and tan are odd functions, which makes cosecant and cotan also odd functions. Okay, so take a look at this chart, write these down, and then we're going to talk about solving problems using these identities.